Tama.
Okay, Docs.
Joel, ikaw ba mag-start or? Okay, ako na. Right. Okay, welcome everybody for the PAASE webinar hosted by Rec10. Rec10 is the research cluster for computer science, machine learning, and artificial intelligence. So to start, we'll first play the video of PAASE and SciNJ, the official journal of PAASE.
gustong mangyari sa buhay nyo, gawin nyo. Pero hindi ko sinasabi, hindi kayo makinig sa magulang. Makinig din kayo sa magulang nyo. Oo, kasi
Kindly mute your mic. Okay.
meron silang na-level mo may...
Sino ba yung mute? Okay. Okay. Distract ako na. Okay. We will start. So hopefully, I saw that we have most of our participants also senior high school students or undergraduate students. So hopefully in the future, you'll be part of PAASE. Okay, and then we also have our official journal where you can submit your research article. Okay, so for our first speaker, he is a Balik scientist, awardee, and a distinguished visiting professor at the De La Salle University, hosted by the Advanced Institute on Informatics, Computing, and Networking, or ADRIC, in collaboration with Enrique Razon Logistic Institute. He's currently a enterprise professor on infrastructure and urban system in the Faculty of Engineering Information Technology at the University of Melbourne, and the president and board chair for the nonprofit International Initiative for a Sustainable Built Environment. A scholar of global standing, he is a recipient of the prestigious James Cross Medal for the American Society of Civil Engineers, amongst other awards, and listed in Stanford University's most ranking of top 2% scientists, now based on his published work in Scopus. Greg has previously worked at Virginia Tech and the University of California in Berkeley in the USA, and Australian National Science Agency, the CSIRO, and has been a visiting professor in leading universities in Europe and Asia. So he got his bachelor's degree in civil engineering at Mapua University, 2 MS and PhD degrees at Virginia Tech, and also he received executive leadership and management training at the Australian Institute of Company Directors and at the MIT Sloan Executive Education. Without further ado, let's all give a warm welcome to Greg Foliente.
Right. So thank you very much, everyone. Thank you also for the host who allowed me to go first. I'm usually based in Melbourne, but I'm currently in Europe for five weeks, and I'm currently in Berlin. So I apologize that this is 2:30 a.m. I told Joel that if I fall asleep talking, he should wake me up. Thank you all. Good to meet you all. And I'll go check sharing that if you can see. I will be, this presentation will be more conceptual and probably strategic in terms of approach rather than mathematical or statistical, because I recognize that there might be a range of interest, but I think also it's important to think in more holistic fashion. So talking about AI, human sensemaking in sustainable development. So there's this ITU event called AI for Good that you probably are familiar with, and every I think I'm not sure every year, but every 2 years certainly, talking about how to advance UN Sustainable Development Goal. But the first thing to say is that it is actually a big contributor to carbon footprint and many other environmental impacts. In fact, the growth of AI is one of the biggest drivers of emissions, and it's only going to get worse because of all the things that we're pushing it to use a lot of resources and wastes as we make a more data intensive and more sophisticated computing. So that's the first thing to say. The second thing is that we live in a planet that has thresholds, and these thresholds include things related to, of course, greenhouse emissions and several other Earth system processes. And out of the various planetary boundaries, we are already breaching some of these safe operating space for the planet. The problem is how to address all of them, not just one of them. You mentioned about the carbon footprint, but there are other things that are interrelated. And the difficulty, of course, is that it's not just living within the planetary boundaries, which in the donut economics, if you have heard the donut economics, it is kind of the aspirational destination. towards a more sustainable future. In that the outside of the donut is the planetary boundaries, like for example the climate change, ocean acidification, chemical pollution, and the like, land conversion, and so on at the outside, and that's the safe operating space. And the inside are the social foundations. And so these are the things where we are interested in social equity and justice, and those like equality and provision of basic human rights, for example, and basic human needs. So the idea is that we should meet the minimum requirement for these well-being parameters in the inner core, while we are not breaching the use of resources and where we put our waste and manage our waste on the outer core. So these are like a very a sensitive space because they're difficult to balance, right? So that's the concept of safe operating space within planetary boundaries with social equity and strong social foundation. So the problem is because, as I said, we've reached thresholds in like some 3 or 4 in some estimates and latest Nature Science Journal papers. The estimate is that we're really on the brink of some of these boundaries. And so a friend of mine, and these are the people I used to work with. I ran the World Sustainable Built Environment Conference out of Berlin last week. So I just came out of it. That's why I'm still in Berlin, and I'm currently running an international energy agency experts meeting on whole life decarbonization of the built environment sector around the world at this time. And the question is taking these thresholds as absolute values. So then the idea is, for example, in carbon footprint, what is the absolute budget for the planet? And then how do you allocate them? How do you allocate them to countries, taking into account the social equity and justice issues? And also, of course, how do you allocate it to businesses, to jurisdictions, to sectors, for example, transport sector versus food agriculture sector versus various types of sector. Who's responsible for what? Because until we are able to allocate them, we don't know how to be able to let people address them in practical sense. So it's a matter of collaboration and partnership. So these are the challenges, and this is the conference that we run virtually with my colleague Thomas Witzkendorf out of Berlin. Previously, I've run various other conferences, international conferences on various aspects of sustainability, like in the city and also with the World Bank on world communities and land tenure, for example. So bringing that to the probably closer to us, to where we have responsibilities in Australia, where I used to work in the CSRO. There's a team there that I used to be part of that looked, for example, on how to address a future Australia that would be economically, socially, and environmentally sustainable in the next 30 years, for example. And the consensus of experts and other, based on other information, that this would entail that there's a shift, for example, in industry, the way industry functions, in urban life, in energy, of course, energy transition that we talk about, in land transformation and shift, and then of course in culture and behavior. So I mentioned this because these are the big topics. And the basic thing, of course, is that these things would change on the basis of place and location or country, because everything is contextual. The difficulty, as we know very well, in places like the Philippines and other disaster-prone region, is that even though we are trying to achieve these sustainable goals, we are hit by these risks, right? There are different types of risks, and they can be nature induced, like hurricanes and typhoons and earthquakes and the like, but they can also be human induced. And the problem is that you can see that in the last, the latest 2024 version, that anything related to data and information and security is now the purple ones is now dominating this. Of course, in recent years, it was the pandemic. And there are things that are always there, including this climate risks. The problem is that they're always there, and then you get recession, and you get war, and you have these things about concurrent risks. They're happening all at the same time. So when we talk about sustainability, we'd like to achieve, for example, the Sustainable Development Goals. So we try to, improve over time the progress based on the monitoring measures and indicators and targets per country. And we can sort of map out possible successful scenarios. The only problem is sometimes it may take beyond, because, for example, the SDGs were set for 2030. We're just several years before that, and we know a lot of them will not be achieved. And the problem is, if it takes too long, it may be too late, right? And so the difficulty is that it's hard, because as we try to make progress, we are hit by these disasters that then sets us back. And so the progress towards Sustainable Development Goals have to be resilient. And resilience concerns are usually shorter term relative to a sustainable concept of intergenerational, for example, to be able to sustain it over many generations. Whereas in resilience, we are concerned that, say, a performance or a service comes back, like your telephone signal. If you lose it, or your electricity, you'd like it back in like an hour, or in electricity within days, or within also hours. So that's the kind of concerns that we decide for. So they are very related. I mentioned it because of the need for both in anything that we do in whatever sector we work in, or systems we design or manage, that these systems need to be both resilient and sustainable for the good of all. Sustainability is a concept that is idealized to have this homeostasis balance between the exploitation of resources and the investments, the orientation of technological development, that they are all in harmony to meet the needs of the society now and into the future. And the operational organizing principle is what we call the sustainable development. Some people have noted that it's paradoxical that there's no development that is actually sustainable, that development per se is inherently unsustainable. So the idea is, of course, to decouple the economic growth with unsustainability. And that's a real challenge. The way we operationalize this in practice is that we simplify these concepts into things that in terms of frameworks of goals and performance measures and targets. And that's where the SDGs come in, and on the basis of planet and the nations as formulated by the UN. But in practice, for specific engineering systems or plant systems, or products, or development of cities, for example, there are frameworks that people use to be able to do this assessment. And just as a quick review, the issue, and I'm introducing all these things because this has implications on the application and the role of AI in addressing these challenges. So everyone's familiar about the triptych. If we value equally economic, environmental, and social dimension, and if you mix them up, so I say sustainability in this concept of triple bottom line is like coffee. So apart from the water, you add your coffee, you have water or sugar. And so then after that, it's a matter of your preference, right? So that's why we have the concept of weak sustainability when the economic approach is stronger and highly prioritized compared to environmental. And you have the concept of strong sustainability when the environmental is more prioritized. So then this issue of subjectivity of values, what you value, that's what makes it difficult to automate some of these decisions. For example, using AI. And I'll get back to this later on. And just to complete the concept, so of course, the concept in the strong sustainability is that everything is grown and goes back to the environment, and that should serve society, and which then is responsible for economy. That's why the environment is important, but we need to overlay it with governance, which leads us to the common terminology in business reporting and financial reporting today. That's called ESG, where economy is already given, and so then the others are environment, society, and governance. And the way we, as I operationalize this, is that we like defragment these issues into this triple bottom line, and anything that's designed or built or planned, like for example, built assets, add to this set of criteria that need to be addressed, which I call end bottom line, because it's not just the triple bottom line, but also the functional and physical performance of that asset when it's the design. So in your house or your car, you would have this scale of the element to the whole system. To in the case of your house or buildings, it becomes a city, and it becomes a country, right? And when you scale it out, and the rest of the infrastructure that goes with it, the roads and bridges and so on. And then the performance, of course, starts with triple bottom line, and then you can add more. And there's the life cycle of this from the delivery to the end of life, and how it's recycled or reused in the end. So this is the framework that is used, for example, in design of buildings in different parts of the world. In Germany, where I am now, they use five bottom line. In this case, environment quality, social quality, technical quality, quality of the process, and ecological quality when they design and assess their buildings. I generalized this into this, what I call NBL back in some almost 20 years ago. Yeah, and we applied it in urban water system, and I teach and do research a lot on this topic on various applications. And this bottom line can be multiple. Like for example, in cities, it can be if you add other bottom lines, 6 bottom line or more. It was in the BMW show exhibit in Munich that I saw this some years ago, where it says sustainability is not just a goal to be attained; it's a mindset that knows no beginning and no end. And so this is quite true in a strict sense, because you cannot really say whether something is sustainable even with the best effort and knowledge, because we're talking about generation, and so we don't know the interaction and the interdependence of the things we decide today, whether they are in fact going to be sustainable, because we won't be around by 300, 500 years to know whether they are. It was the former professor, retired professor from Harvard, who was an associate editor of the Proceedings of the National Academy of Science, that said this in his editorial some time ago about sustainability science. It says, sustainability science research is seeking to support the integrative task of managing particular places where multiple efforts to meet multiple human needs interact with multiple life support systems in highly complex and often unexpected ways. So I just showed you how we simplify this in practice, right? Taking them into this elemental, social, environmental, and so on. But when you think of it in first principles, this is in fact the challenge, that this is interdependent. It is interacting and supporting many different things. We don't even know how complex they are until something happens, and often unexpected, a lot of uncertainty and a lot of unknown. And so when we'd like to address this kind of level of complexity, we needed all the help we can, and so we turned to technology, right? And of course, that's the purpose of science, is to know more and to be able to address these important issues. So most are familiar with this quote from T.S. Eliot, the poet, who said he presaged in this poem one of the biggest challenges of the information age, when he posed, "Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information?" And this is very prescient, especially for everyone who needs to make a decision, because we need to be informed in making decisions. And in society, for example, in an event where there's a need to make a decision, like in a disaster event, there are many people who are making decisions of different types and relying on different data. And so this is the potential where we deploy technology and data and methodologies of turning these sets of data into something that we can use for decision. But where does it stop, or where does it begin, and where does it work? So we try to, this is the framework for Smart City Enterprise Framework for Open Geospatial Consortium that forms the body. So you have the sensing layer at the bottom, then you can put the data layer, and then you have the business layer and the application layer. And obviously, when you have all this data set ingested into the system, then you can do all your analytics, machine learning, and AI for various kind of purposes. And different users, we can expand into these stakeholders and decision makers, as I said, that in the end will have to make a decision rather than letting the machine do the final decision, right? So in the end, it's still people. And some people like to automate everything, and this is part of the probably challenge and warning. I skip that. So we've done a lot of work, and many people do the same thing of collecting a lot of data, putting them in these kinds of platforms with these kinds of frameworks for different purposes. In Australia, for example, we have the Australian Urban Research Infrastructure Network. We have all kinds of data network for different purposes that's funded by the federal government to collect this data for researchers and experts to be able to link them for different purposes so that we can run all kinds of different analytics and, of course, develop AI tools and platforms. And of course, we move them up as well, not just digitizing the information, but then also now putting them in visual form through digital twins. And so there's a combination of the visualization with the kind of capability for analytics, including various types of machine learning and AI approaches. The problem is that in reality, the first context that's important in any research, in particular in sustainability, as mentioned by Clark in the PNAS article, it's about place. So everything is about place, location or place. And so the place context is very important, where you have the natural environment layered with the built environment, layered with the people, socioeconomic environment where all the things happen. And this is where the interdependencies happen and where it's hard to track because they're different for every city or every location. It was Churchill who said, "We shape our buildings or our roads and bridges, and afterwards, our buildings and our roads and bridges shape us. They determine our own lifestyle and our socioeconomic activities." And so when we do modeling and try to figure out the relationship of these things, in a complete sense, you have all these kinds of data that are available. There's this that we can get. And so this is from one of our projects on parks. So we collect objective data sets. We collect subjective data sets. And of course, now, not available in the past, we can get this observed data set through sensors of all types, Internet of Things and CCTV, social media, your mobile phone, and so on, which is most of you use in your research. But we all tie them to this location space because the context of space and location, as I said, is important. And then you can do all kinds of analytics and association to figure out the problem is when it's so complex, things don't make sense. We need a lot of data. So there's the concept of big data, right? Is that you have a lot of N, but the depth of insight is low. And in fact, it's context free in most cases. And we infer context back based on other set of information we know. And then you have thick data, like most things in qualitative research, but they're very thin. So if I visualize them, it's super thin, but it's very insightful. So the thing is that we need this rich data in the end. And so it is the combination of these different types of data that it becomes very useful for providing a more well-rounded information about the problem that we are dealing with, right? But on top of this, I show you the layers of a city because simple analysis showed, for example, the layering, and this is just transport network. And this is a very complex, very, very difficult mathematical and network science problem, multi-layer networks. And this is the simplified version. And so there's a lot more of this that it just really exponentially blows up. And this is in urban AI, for example, you can see on the left, all this layering and the kinds of requirements needed to be able to run many of the applications. So usually we would research a strand of it, for example, rather than the full set like this. And there's opportunity to use both the typical scenario simulations we would run through mathematical models and a combination of numerical mathematical models, statistical models, together with large AI models. And you can use emulators to go one way to another, from one way to another. Now, recently, most of you would know Jan LeCun. Of course, everyone knows Elon Musk. They are in the newspaper in the last probably several weeks because of their spat and Twitter. If you're not familiar, that's an interesting story. You can read it in Nature. Even Nature picked it up, not just the newspapers. But I only point it out to talk about LeCun, who's very consistent in this. He is, of course, an AI guru at New York City University, as most of you would know, but also he works as the research director executive at Meta, Facebook family group of companies. And he says that the large language models will never appear or reach the human level intelligence. The reason is because they're only using words. And regardless of, even if you can get all the words in the world, it's not enough because of all the other senses that humans have that don't turn into words. So we're talking about the touch, the visual, the hearing, and all the things that we take for granted. And they all integrate in our mind, and we use very, very sophisticated filters, which one to keep, which one to give. And these are so far away from the capability of even the best models that we have, for example, in AI. Interestingly, Dave Snowden, who dealt with some IT, but he's not known for IT. He was a guru in knowledge management. He used to run the IBM Knowledge Management Research Center. And he now runs Cognitive Edge. So he talks about 7 principles of knowledge. And there's a YouTube around where he talks about it. And he wrote an article a long time ago about this. But I'm not going to go deep into this except to say that, of course, the most what they call recognized issue is that tacit knowledge can almost difficult to package, to pass on. We can write things, we write papers, we write books, but there are a lot of other information that's not reflected in written form. And this is very similar to what Jan LeCun talks about, that while we can write many, many things, it doesn't capture the things that are in the mind of humans, essentially completely, because there are other things we know, and we only use them when we need them. They only come out when we need them. And when we don't offer it, no one else knows about it. And so this is part of the thing. So they come from a very different perspective, and yet they agree on this aspect. And so David Snowden later on built the sense-making framework called Connevin, and it's been studied by other academics in terms of their role in decision analysis. But Snowden himself, who I know personally, I've hosted his visit at the University of Melbourne some years ago, and because I follow the Connevin framework for various applications, which he wrote, by the way, some of the basis of this in the Harvard Business Review article back in 2007 that has a very good, healthy run during the COVID pandemic, because this is obviously very apt for decision makers during COVID. I do talk about the Connevin framework in various contexts. So it's, as I said, it's about context and vision. So here I talk about it in its application in the role of AI for very, very complex issues in the world. And that's why I started this talk, where how complex sustainability science is. We can study strands of it. You may be studying certain elements of it, but the whole of it is hard to understand. So let me pause from there and say that in the Connevin sense-making framework, the idea is to find the context of the environment you're in. And there are 5 types. There's a disorder in the middle, but the important things are these 4 called obvious, complicated, complex, and chaotic. In the obvious domain of decision-making, the idea is that the cause and effect are well known. So in any problem or scientific research issue or research question, where the cause and effect, you're just trying to figure out cause and effect, you would sense what the category is. Once you have categorized it, then you say if A and then B, then you just follow a best practice procedure and you can just tick. So this is very, very good with for AI and machine learning algorithms for these kinds of problems, or you have many options in A, many options in B, that kind of thing that we do in statistics. And then you can become more, of course, what you call sophisticated and take more things. So this is a definite area where you just use them like automatic and set them. The second domain is called complicated, and in complicated, there's no best practice because you need expert knowledge to find out that if the problem is type A, then the solutions are 1, 2, 3, and then you have to figure out which 1, 2, 3 fits that problem well. If the problem is type B, then you have 4, 5, 6. And so then there's this categorization. And then depending on the various context, then you would deploy the good practice that are specific to that problem. And so you see here, you're starting to become a little bit more nuanced in a way, but it's still very, very good a field for applying AI methodologies here, especially as you make your algorithms more sophisticated. So that's no problem in this area. Complex and chaotic is a problem. So the one on the left field is a problem. So because in the complex domain, we don't know what cause and effect are. We don't know there's emergent property. In chaotic also, there's a chaotic. So the interdependencies are not well known. And so you cannot understand the whole thing because of this lack of we can understand the elements, but not the whole. And so in complex environment, like in sustainability, then we can choose different strands. And so we publish papers that are very specific line of inquiry within complex that can that moves actually to the complicated at that level or the obvious. But the whole of the complex is hard to get. Having said that, we can do an iterative approach where if you don't know anything, you may run a blind analysis, and then given insight, you may explore certain specific aspects of it to learn more about it, and then build your knowledge of the more complex combination of it over time. The other thing to deal with in complex and chaotic is another approach outside of just collecting data and then modeling them, which is has a big gap between collection and modeling, is these feedback loops that are almost instantaneous or near real time. And so the IoT and sensing and data feedback loops are very important. And so then the approach in the complex and chaotic is this what's called complex adaptive approach. And what it means is that you need to determine what is a positive outcome that you're looking at, that you are interested in, and what is a negative one. You have to determine what is a positive outcome and a negative outcome. And then, depending on the feedback that you're getting from your system by deployment, the sensors doesn't have to be those IoT and physical sensors. They can be human sensed if there's a way for you to do that. And then the idea is that when you collect the data, when you're seeing the positive response, you'd like to amplify the activities you're doing to continue the amplification of that. But if the outcomes you're seeing is the negative, the one you don't like, then you dampen, you change the direction. So this is the complex adaptive approach. And so in this scenario, you can deploy AI in, again, as I said, in the use of the data sets and in specific problems very, very effectively and very, very fast. And that's what you need to give you certain information. But it's hard to automate the final decision making. Now, an old paper that was written by Luis Betancourt, who used to work at the Santa Fe Institute, the Complex Systems Research Center in Santa Fe. He has since moved on at the University of Chicago now. But this is an excellent paper on super sensing and the uses of big data in cities. And it's essentially, he was arguing the same thing I'm saying here, that you need to know where they're most useful and when they're not, and when you apply machine learning and AI techniques. And it depends on the very specific lines. So again, this is very compatible to the concept of the Conifin framework being your framing for finding out where they may work best and where they probably are not reliable or even useful. And so I wouldn't go into the detail of this except to quote him and recommend that you read this if you have the opportunity. He says, in other words, sometimes you don't need to be very smart if you are fast enough. This is the logic of modern engineering and more precisely of feedback control theory. The crucial issue is that of temporal scales. Every system has intrinsic time scales at which problems develop. A few seconds in the case of a car on the road, for example. Cycles of measurement and reaction that avoid such complex problems by simple means must act well within this window of opportunity. So, the automation and decision making can sometimes be automated like that and help you avoid problems. And but again, they're deployed in very specific cases. This concept of the Conifin sense-making framework is now applied in the U.S. Homeland Security, the way they manage crisis and disasters, but also in the EU through this little booklet called Managing Complexity and Chaos in Times of Crisis. The Canadian government uses the framework, for example, for training some of their executives. So in closing, I'm just saying, as I said, I'm not going to the mathematics of this. I have had papers on various elements of
we will be
deploying.
having some on hand to help ensure the project integrates properly. But
yeah, so to close, then I just say AI for good, question mark, right? Because it depends. The Conifin sense-making framework provides a helpful tool for categorizing problems based on complexity and guiding decision-making strategies. While AI shows great promise, its black box nature can hinder human understanding and active and nuanced consideration of the trade-offs. And in sustainability, it's all about trade-off. That's why I talk about coffee and subjective values. So then that's why in the end, you have to make a decision based on what you value most. You cannot almost automate that. We need to ensure there are appropriate, responsible, and effective implementation for a sustainable future. And so this is when you determine the type of problem to figure out the best approach and technology to use. where you can use them as for direct applications. Definitely use them because they're great, super great, and it's going to be ubiquitous. Everything we do and we face now into the future will have this AI aspect of it in various levels, and so we should also be advancing that in our own work. And where human AI collaboration is necessary, and where you should avoid them, and this is pretty, I think, straightforward. So with that, I'd like to thank you all. Sorry that it taken longer than you expected.
Thank you, Greg. Questions from the audience, you may either unmute your mic, raise your hand and unmute your mic, or you can also type your questions in the chat box.
Joel should have a question.
Yeah, actually, I'm readying for my question. I can actually relate to what you're saying about using sensors. And then, of course, we had this small project at our university where we are using CCTV camera networks to measure the traffic situation in the city. Actually, because we understand that traffic is a really complex problem in the country. In fact, there's a group of, if I remember, scientists from the National Institute of Physics who are just trying to model the traffic dynamics on a particular intersection. And I understand, I know now to understand that even the modeling of different kinds of intersections would entail different issues, like a four-way intersection versus a corner intersection, all of those things. So that's why we're really, really careful to advise people when they ask us, can you use the camera sensors to create intelligent traffic signals? I answer with caution that it's a very complex scenario, something that even our team, with our best efforts, cannot do. So actually, I got struck by the quotation with your quote from Winston Churchill that says that the building shapes the activities of the people. And I could also say the kind of data and information that is being given by the different sensors also shape how you analyze and respond to this situation. So I could see the analogy. So my question actually is, if we're going to do this by phases, what would you suggest? No, so knowing the Philippine context and so many things happening, how do you suggest that if we're going to build a sensor platform with a corresponding data platform, how do we do that?
Yes. So you're talking about for human mobility for transport, right?
Yes, for transport.
Example, yeah. So let's take
for
that example. So obviously, we say it's context dependent, and so when you have one type of intersection in that case, and you may have lots of roundabouts, and you'll get lots of roundabout types. Then you get better with roundabouts. But then it's the different types, right? So when you have a four-way stop and you have this or that kind of stop, or a five-way corner, so which means I need lots and lots of those as well. And then when you build and put all the data set together, we can run some algorithms to determine whether the data being seen is in fact a four-way or a roundabout or a five-way. And then it follows from there, right? So that's usually what I would say is the categorization, the complicated domain. Yeah, that's a complicated domain. So that still would work there. You just become more sophisticated. You just need more data, and you need more sophisticated with your algorithm. So I think that's still okay. So the one I'm trying to warn is that not all problems look like a hammer that can be hit by the AI nail. I think that's the metaphor I'm saying. Yeah, because I've met a lot of my colleagues who are like they're trying to solve with AI or machine learning, and I warn them about that, especially when you scale the complexity of the problem. Yeah.
Okay, thank you, Greg.
Any other question from the audience?
Hello, ma'am. I do have a question.
Yes,
This is Dr. Kabelian. Sustainability, and I guess my question also segues with the first question. You're talking about an intersection, but for Manila, I was there last December, the whole city is congested. The whole city is congested. So when we talk about AI, as I understand it, are based on models. And you have to train your AI model to some model that would be, good for everyone. So the question, just to be short, is will you have to say that a resident cannot buy a car anymore in Manila when a certain threshold goes over the AI model that it cannot sustain the traffic congestion of Manila? So this is an existential question. That is a very existential question for Manila.
Yes, yes, I completely understand. I get the same frustration, but there's uh, there's a difference between political, social decision, right, and the deployment of technology. So it's always overridden by decision makers. That's why I take them as outside the system. And so they still need to put thresholds, for example, for certain things. So it's a policy and political decision and so on. So we talk a lot about this in all kinds of scenarios modeling. And when I work with policymakers, regardless of how good and validated our models are and the way they look nice and realistic, that if this thing happens, this is the outlook and so on, and they're built on the best science and the best data. In the end, it's just information given to them on the table, and it's just another set of information, and then they would either take it in or ignore it, or take it only partially in. And that was my own experience. But having said that, as a researcher, I tell my colleagues that that shouldn't deter us from trying to give them these kinds of good models and good information, because that's our role. Their role is to make those kinds of decisions. And whether they follow our advice or not, that's on them. But I will do my role.
I had a question at the risk of eating into the second talk. I appreciate your caution around AI, and also it seems like there's just incredible competitive and economic pressure between companies to drive down labor costs and increase productivity, and even nations, like their national security arguments to just go faster and faster. And so, when I read the news and keep track of developments in like language models, it isn't slowing down at all. Like it's only accelerating, even though people are increasingly concerned about it. And in our own lab, even we use it all the time now. It's so useful. So I'm just curious, like, what do you think, if at all, it takes for society to actually like slow it down? Like what would you expect like actually happen if that was the case?
Yeah. Look, Elon Musk tried to stop it, and it's not just him. This is like, I think 2 years ago, when ChatGPT came out and became popular. There was a group of scientists who tried to do a petition to say, look, we're not ready with the ethics, with this blah blah blah, with the safeguards. Therefore, you should stop or slow it down, right? Well, it won't happen like that because people have different motivations, right? So who's going to police that, even if you want to do that? So so that's why it will explode. It is exploding. Everything has AI. You can do everything with AI now, and so that's why I said it becomes ubiquitous. It's everywhere, anywhere. So with my own students, my PhD and master students, I say you don't avoid it or fight it. Use it yourself for almost everything you can use it for. If you like to run experiments or do this or test ideas, test your research question, use it, but be aware of all the issues. In fact, every time you test it, you should be testing it. If you know what I mean. Every time you're using it, you should be testing it. Because you know better, right? Or you can make decisions. And in fact, you can prove or disprove it. And that's always the case. So always, especially with critically minded scientists and academics like us, we should be the one pushing it and probing it. And so then I train all my PhD students now to do the same, so that as soon as they graduate, they're already ready to continue probing and checking and testing. Yeah. Don't avoid it. Play with it. Know how to handle it, and always, because it's always evolving, right? It's always going to change, but it has exploded. We cannot stop it.
Okay, thank you. So before we proceed to the next speaker, let's have a quick group picture while everybody's here. Okay, I'll remove
Okay.
the spotlight. Okay.
Okay.
And
I'll also help in the capturing the everybody. Okay. Okay. Let's wait for everybody to open their. Let's wait for everyone to open their cameras.
Okay.
Okay. Okay. Yeah.
1, 2, 3. Smile. Page 2 po.
Okay.
smiling because you don't know whether you're in page 1, page 2.
1, 2,
It's
3.
actually shifting.
But for sure, the co-host will be in page 1.
Page 3 po. 1, 2, 3.
Mhm.
Smile. Last page. 1, 2, 3. Smile. Okay na po.
Okay, thank you.
All right. Thank you very much.
Thank you.
Sorry, Lawrence, I have to sleep now. But
Yeah,
this is
thank you very
recorded,
much.
available in the website, right?
Yes, they will be.
Yeah, this will be.
Yes.
Yeah.
Yeah, get
Thank
some
you very
sleep.
much, and hope to meet some of you soon, or in person.
Thank you.
Hi.
Thank you.
Okay, Feb, can you
Okay.
share the slide? Okay, so for our last speaker for the day, he's an associate professor in Duke's University, Department of Molecular Genetics and Microbiology. He is also, I think, the director of the Center for Genomics and Computational Biology. While at Duke, has been named one of the 10 scientists under 40-year-old to watch by Science News. And their work has been recognized with Innovator and Investigator Awards from Bureau Wellcome Fund, the Chan Zuckerberg Initiative, the Cyril Scholars Program, and the Arnold and Mabel Beckman, Hartwell, Alfred P. Sloan, and Damon Runyon Foundations. And then he was a junior fellow at Harvard University's Society of Fellows from 2010 to 2013. And he got his PhD in computational systems biology from MIT. And he completed his undergraduate studies from Columbia University. Okay, without further ado, let's all give a warm welcome to our next speaker, Dr. Lawrence David.
Thank you so much for the invitation to speak. Let me just see if I can get the screen sharing working properly. Can people? Oh wait, no, that's
Yes,
not
we
it.
can see your slide.
Yeah, it says it's not. It says it's paused. Can you see my? Did that slide advance?
This is the first. We're seeing the first slide, the title page.
Okay, but it didn't go to the next one.
No.
No,
Okay,
it
let me
didn't.
try. Let me try that one more time then. Sorry. Hmm. And then could I ask while I'm fixing this, what time does the seminar usually end? Because I can go faster if I need to.
We can end like 10:30. So you have 1 hour, so including the question and answer.
Okay, well, I'll try not to take that long. I imagine people have places to be. Okay, is that? Oh, why did it pause again? That's so strange. Every
So
time I
when
go full screen, it pauses my share.
Hmm?
So it's not.
Or perhaps you play first and then you share the.
Yeah, but this is working, right? You can just see it like this.
Yeah.
I'll just do it like this because I don't have any animations anyway, so it'll work fine.
Or do you
Um,
want to like at least keep the right side, the slide layout closed?
Sure, yeah, I can close that. Close that. Good idea. Uh, Okay,
Okay.
how's that? Okay, can people see that?
Yes.
Great. Okay, so thank you again for inviting me to speak, and I'll talk about actually mostly unpublished work today. And so it won't necessarily be an overview of what our lab does. It's actually only one or two smaller projects, but that we're actively working on and I'm very excited about. And what we work on, um, I feel like is a dream for at least me, which is we study food in our lab. And so what I'm showing on the left is one of the projects we do now is we go to the supermarket, we buy one of every food and we sequence it. And then whatever's left over, we just eat. And so I'll tell you though why we sequence them. Okay, so historically, my lab for the past, I guess, I've been at Duke for 11 years now, and even before then, for maybe the past 15 years, I've mainly studied nutrition and the microbiome. And what we have used is food as a perturbation that alters the microbiome, and we use that to understand its ecology. So examples of this include just in the last couple of years, we've done clinical trials where we recruit volunteers and we feed them different kinds of foods that we have designed to alter the gut microbiome. And so in some of these studies, what we found that sort of surprised us is that the people who respond the least to, I should say, the people who respond the most to microbiome targeting foods actually were eating the least amount of that food to begin with. So specifically, if we have a fiber intervention, it turns out the people who respond the most to fiber interventions normally eat the least fiber. And then something else we found is that in our fiber interventions, the microbiome learns how to respond to the intervention very quickly. Within a day, it seems, of eating a new food, the microbiome can change how it metabolizes it, and almost like a memory. And this is also relevant, it turns out, for folks who are for hospital patients. So in collaboration with Anthony Sung's group here at Duke, we've been looking at patients after bone marrow transplant. And what happens is that when they take a fiber supplement that's meant to, or I should say a prebiotic supplement that's meant to stimulate the gut microbiome, it helps, in this mouse model, mice live longer after they get a bone marrow transplant. So that's what our lab normally, or used to work on a lot, which was the microbiome and nutrition. But one thing that happened in our studies is that Or as you can imagine, all of these sort of presuppose that we know what people have been eating. And it's very relevant to the microbiome studies, how much, say, fiber or plants or meat people consume. But what's always been very frustrating and challenging is how hard it is to get those data. So what I'm showing on the right is a standard food frequency questionnaire that's used by the National Cancer Institute in the US. It's a brutal test, basically. So this is page 33 of 40. There are probably several hundred questions that are asked, and they're very kind of like tedious and monotonous. And also it just is almost impossible to frankly remember kind of these fine nuances of how people's diets are structured and how frequently individuals consume all of these different kinds of foods. And especially when you ask people to remember going back like a year. And so it's kind of remarkable that, to me, as someone who did microbiome work, that this is a tool that's still used for nutrition research. And as you can imagine, there are a number of kind of biases that are associated with it. So people might not remember certain kinds of foods because they're kind of embarrassed to say that they've been eating things, especially chocolate is what we notice. A lot of people don't want to self-report that they eat chocolate. They're very slow. Takes like 45 minutes sometimes to fill out these things. You also have to be like pretty literate. So babies can't fill this out, or very senior people who might have, say, cognitive decline can't participate in these surveys, especially in settings where you have many different ethnic groups that speak different languages or have different kinds of foods. So there's, pumpkin pie and meringue pie, but there's no like ube pie, right? And so my kids love ube pie. There's no box to check here. And then also, you have to kind of apply these sorts of tests sort of in the moment if you care about people's nutrition at that time. It's very hard, in other words, to do retrospective work. You can't really ask someone what they ate 3 or 4 years ago. You can barely ask someone, what they ate 4 days ago. So there are a number of drawbacks to these kinds of tests. And what our group has done is just sort of respond to this call. And I'll mention that, you don't have to kind of take my word for it, that there's a need for more objective forms of basically dietary measure. The NIH in the States has put out multiple funding calls that are basically requesting scientists develop new kinds of methodologies for measuring what people eat in, again, accurate, objective, and easy to use ways for people. So our lab has been developing a technique for this, and we were actually inspired by ecologists, so people who have nothing to do with humans. So one of friends and collaborators, Tyler Cartzinell and Rob Pringle, who are at Princeton and Brown universities, were telling me one day about a study that they were doing in herbivores in the African savanna. And what they did was they were studying what animals like this dick on the left eat, and then comparing it to what other animals were eating, and comparing diets across all these different large herbivores. And I remember this kind of blew my mind because they were measuring dozens of different plant species that these herbivores were eating. And obviously they weren't giving the dick a diet survey. They had some other way of doing this. And it turns out what they did was they used DNA sequencing. And what I'll share with you is how we've adapted this technique that was originally developed now for animals and applied it to people. And so the way it works is that everything that we eat, with the exception of basically salt and vitamins and minerals, every single other thing we eat came from something living, and all living things have DNA in them. And what happens after you eat things is that your body digests them, but then afterwards they get excreted and pooped out. Probably 99% of the DNA that we consume gets excreted, but even like the 0.1% that we think survives is still millions of copies of DNA per gram that are ingested and consumed. And And so what you can do then if you have access to human stool samples or waste samples is we can design primers or DNA primers that bind certain marker regions of DNA. We can sequence that or amplify those regions, sequence it, and then we map them to reference genomes that have been curated by two former students in our lab, Aspen Reese and Brianna Petrone, over the past couple of years. And so this is how we can do a survey of what people eat. And for anyone here who does kind of microbiome research, this looks a lot like microbiome research where people sequence bacteria, but instead of sequencing bacteria, what we're sequencing are plants and animals. So just going back to kind of what I was telling you about before, the challenges that are associated with self-reports of diet, we think that genomic biomarkers have address a number of those advantages, because now you don't really have to rely on people to remember things. In fact, you don't have to ask people to fill out long surveys anymore. Also, we can actually go back and do things retrospectively. So as long as there's bank stool, we've gone back for stool samples that are almost a decade old and gone back and been able to reconstruct diet samples from there. We could probably do it even for much older. I'll mention, oops, sorry. Our lab has done a fair amount of work to optimize the experimental side of this. So there's a lot of DNA extraction, PCR that's associated with this. And so we've developed protocols for doing this more efficiently and more reliably. The biggest lift, though, was, and this is still ongoing work now, that Paul Yu, who is on this call, has been contributing to, has been building up a reference database of plant and animal species that people eat around the world, and so that we can identify all the different kinds of plants and animals that everyone eats when we sequence them. So I think our reference now has over 800 plant species in it. That includes, we think, most of the 100 commercially considered most important commercial crops that are tracked by the FAO, and a majority of all the crop families. I want to say there's several hundred that are tracked by the FAO as well, internationally, and we have those two in our reference too. So we've validated this or worked on validating this a number of ways using forms of controlled feeding. As I said, we can go back in time basically to reconstruct now diet. And we happen to have stool samples from a feeding trial that I had done with Peter Turnbow back in 2014, where we had recruited volunteers to either eat foods from a specific plant-based diet that we designed here on the left, or from a ketogenic diet, which is on here on the right. And I'll just mention, because people always ask, the food was cooked in these diets, but it's just looked prettier this way, I guess, for the photographer. When we applied this sequencing technique to those stool samples that we had saved, indeed, each of these, the technique appears to be able to separate and tell apart when people are eating like a vegetarian diet. So each dot here is a stool sample from a different person, and they're colored by whether or not they were on this vegetarian diet or not. And this is a form of dimension reduction called principal component analysis that we can overlay and identify the specific plant species that are causing these stool samples to separate in this visualization. And indeed, the species that drive the variation are what we expect. There are things like oats, lentils, and squashes, which is what we were feeding to the volunteers. And so I'll mention too that another way that we've been thinking about for validating this has been in a set of study participants here in Durham, North Carolina, and comparing to when they fill out standard dietary questionnaires. And we had two cohorts of people who were filling out questionnaires and, again, also providing us with stool. And what we found is that on the y-axis here is our food-seq technique, our genomic sequencing technique that's applied to stool. And one way that we measure sort of the output of that is just counting the number of plant species that people eat. That's the y-axis. And then each of these rows here is a different cohort. And on the x-axis are different measures of dietary quality that we scored using people's surveys. And what we found is that different measures of dietary quality, like the healthy eating index or the healthful plant-based diet index, if you scored higher on those surveys, we could predict that in a statistically significant way just by counting the number of plant species that we saw in folks' stool. So what it's basically telling us is that DNA sequencing of human stool is a biomarker of dietary quality, at least in these cohorts. So finally, one initial thing we did when we were first developing this technology has been to study diet in a cohort of individuals who weren't able to fill out those really long food frequency questionnaires that I was showing you before. So this is a collaboration with multiple folks at Duke University, shown here. And what we were doing was, this was a cohort of adolescents, so kids between the ages of 10 and 18, many of whom were from minority groups as well as on government assistance. And we had access to stool samples for them, but not dietary data. And when we applied our food-seek approach to this, we saw what I thought to be interesting and compelling patterns. So some of those patterns were maybe more expected or intuitive. So as for families who unfortunately were food insecure, they had a lower diversity of plant species in their kids' DNA, or in their kids' stool, I should say. And also as families grew wealthier, their children were seeming to be eating a wider diversity of plants. So that's on the y-axis here, so we're counting the number of plant species seen in kids. But other more surprising things I thought were here as on the left plot, as kids got older, their diversity of plant species that they seem to be ingesting went down. It turns out that we think it's because kids, as they're getting older, are leaving the house more to have more meals out, say with their friends. And also kids with obesity actually had a higher diversity of plant species in their stool. And that was surprising too, because typically people think about, I'd say dietary diversity, at least in this in the US settings, is being protective against obesity. But here it turns out was a risk factor. And I'll get into later in this talk why I think that was taking place. Okay, so this is the part now where I'll transition and share some of our more recent work that's still unpublished. And what motivates it now is just an appreciation of the beautiful breadth of things that people eat around the world. And honestly, like my desire to just study food and like all the different kinds of meals that people eat. So in particular, things that I are struck by is just the astonishing diversity of plants and animals that potentially people have evolved to eat over millennia. So it's estimated that there might be 300,000 edible plant species on the planet. People don't really eat all of them. Maybe about only 7,000 are regularly eaten. And as I mentioned before, though, what are considered commercially important is a relatively small fraction of that, only about 100. So we actually don't always collect, or usually don't collect data from people on the vast majority of things that get eaten. So foods that are, say, specific to a given region, or might be considered illicit foods like bushmeat, don't really get tracked in typical surveys. Also foods that, especially in terms of like global epidemiology, things that aren't really considered to contribute a lot to caloric intake might not always be tracked. And then finally, it's kind of hard, as I was alluding to earlier on earlier slides, certain kinds of foods might just have different names in different parts of the world, or are just kind of hard to track in a standardized way across many countries. And so, for example, many vegetables by the FAO are at least often categorized as into one category, even though they're actually quite different things. So one thing we've done with colleagues now is try to look broadly at just what are dietary patterns around the world as measured now by DNA sequencing. And so this has been a collaboration between folks in our lab, Bernard Patron and Ben Dubert, and we've been very grateful for a collaboration with Lara Dugas and Amy Luke at Loyola University in Chicago. And so Lara and Amy Luke had set up a cohort of folks of African descent in several places around the world. They're in the US, the Seychelles, Jamaica, South Africa, and Ghana. And they collected stool samples. And these people were selected in part because they're at risk of cardiovascular disease. So we applied our food-seq methodology to several hundred stool samples that were collected by Laura and Amy's groups. And now what I'm showing you here is kind of, in a way, just like a high-level view of like what are the patterns now that we see in how people eat across these cohorts, as well as we've combined them with samples that our lab has collected here in the US. And so again, this is a principal component analysis. And just because you'll see a couple more of them now, I'll go into a little bit more detail. Again, each of these points here is a different stool sample from a different person. And how close they are in space reflects how similar those two stool samples were in terms of the abundance of each of the different dietary plant and animal species that we measure. So we measure across hundreds of different plant species, and depending on if samples are more similar to one another, they'll be closer in this space. And if they're more disparate, then they'll be further apart in the space. And then each of these arrows here with a given plant species is identifying what are the kinds of dietary species that drive variation across these axes in this principal component space. And then finally, they're colored, the points by, or the individuals are colored by where they originate. And so one pattern that kind of immediately jumped out at me is that if you, oh, sorry, it's still like, it's a little pixelated. Okay, computer's catching up. It's like a little sleepy. You have to forgive me. It's kind of late at night here too. So what the pattern we see is that along this x-axis here, which is characterized by these plant species, chocolate, corn, soybeans, wheat, and potato and pepper, people partition along this x-axis and based on whether or not they're eating a lot of these plants here. And so there are a couple of interesting things about this axis. First, we don't all acknowledge and know what form these plant species are coming in. It's possible that the corn, people are eating whole corn. We don't know if they're eating whole corn or like cornflakes or tortilla chips. Or the soybeans could be tofu, for example, or they could be like soybean oil. But we have some, I'd say, like suspicions that many of these things are actually coming in more processed forms. And the reason we have suspicion of that, when we see points out to the left here, is first, people who are out here to the left are more likely to have a higher BMI or body mass index. And also something that we find really interesting is that as you get out to the left here, we're counting like a higher number of plant species, which, as I had hinted at before, has actually been often associated with more processed foods, having more ingredients. But I'll kind of back that up in a second why I think that's the case. So as I said, there's something interesting about these sets of plant species, chocolate, corn, soybeans, wheat, potato, is being associated with higher body mass index. How do we know then what is it about those plant species that might be leading them to increase folks' risk of having overweight or obesity? And so I guess getting back to Greg's talk before mine, ChatGPT is irresistible, and we sat down and coded ingredient lists from over 7,000 foods tracked by the USDA, where those ingredients were listed as by their common names, things like eggs or sausage or hash brown. But what we had to do is, because we don't measure food in these forms, we measure them as Latin, or basically as species names. We use ChatGPT to recode basically tens of thousands of individual ingredients based instead into like their Linnaean Latin taxonomic name. And it really saved us probably months of work, of incredibly tedious work, and it does it in minutes. It's astonishing. So what we found by that, which leads me to think now that these plant species that I was just telling you about are actually a marker of processed food intake, is we saw first that when we recoded all of those ingredient lists, the more processed a given food was, and sorry if you're not familiar with this NOVA processing score, this is a kind of measure that was developed by a group in Brazil for characterizing how processed foods were. So ultra processed foods here are a 4, and then foods that are basically raw or unprocessed are a 1. What we found is that foods that were classified as ultra processed were indeed much more likely to have more more plant species in them. So in fact, this has changed now how I go food shopping, because I think it's pretty well accepted that ultra processed foods are probably not associated with health. I can recognize an ultra processed food by whether or not it has 4 or more different plant species on the label. That's sort of what this analysis told us. And if we look to see what are the most commonly found plant species in ultra-processed food, there are many of the foods that characterize that first principal component I was telling you about. So corn, wheat, soybeans. These plant species, when we see them now, they just tend to significantly co-occur in ultra-processed foods. You'll probably notice, though, that the most common component of ultra-processed foods, which is sugarcane, which is used to make or put a lot of the sugar into some of these foods, we don't detect here. And I do think that that reflects a limitation of this method. So certain kinds of ingredients, if they're really, really highly refined, like granulated sugar, there probably just isn't DNA left to detect. But again, I don't think that that's like fully a problem for us to detect people who are eating highly processed diets, because other components of that, like or staple crops like corn, wheat, and soybean, it turns out we can detect residue of those foods. So yeah, I think one of at least my personal takeaways from this is it kind of challenges this notion of like eating broadly or eating a lot of different plant species. And sort of evidence of this that kind of blows my mind is if you sit down and count just the number of plant species in McDonald's, Big Mac meal with a coffee, you get almost 20 different plant species in certain kinds of foods. So as I said, this makes me rethink kind of how we think about diversity when we characterize global diet. I'll just skip that for a second. So what the other axis here that I thought was super interesting is this y-axis here, the second principal component. So people partition in our cohorts now. Actually, when you look across country, you really only see red points up here. These are samples from the US. And this axis here is characterized by spinach, cabbage, lettuce, and carrots. So to me, at least, these look a lot of like what you would see in basically a garden salad. And this doesn't occur just in this cohort too. We've assembled larger cohorts with additional collaborators where we've included samples from children who are in Kenya as well as in Nicaragua. And we see the same pattern where when you include even samples from other countries too, American samples, which here on the right are pink, are the only samples that tend to have, again, lettuce, cabbage, or spinach in them. And this is something that I find really, really interesting. And to me, points at what I think it might not always be appreciated, at least in some forms of global nutritional epidemiology, for what drives dietary variation like between continents. So namely, like that salad might actually be, or differences in salad intake might be kind of a relatively unique feature to sort of OECD economies. And like, why might that be the case, or does that actually make sense? As many of you might know, in certain settings where traveler's diarrhea or sort of enteric disease is of higher risk, a very common thing to do is to basically avoid raw vegetables. So certainly I know that when, if I travel to certain regions that are shown here, one of the first pieces of dietary recommendation one gets is to avoid uncooked vegetables or foods, or basically if something doesn't have a peel, you don't eat it. Another kind of thing I think this points to is just kind of the caloric density and cost of a lot of these plant species. So, and this is sort of a bit of an ad hoc analysis that we're still refining, or at least I'm still refining, but that when you break it down to kind of calories per dollar, these plant species here are some of the lowest. Lettuce, spinach, cabbage, if you just count, or at least here when I go to like a local supermarket, the number of calories that I can purchase per dollar for those things is an order of magnitude lower than like starchy fruits and vegetables, which we see more commonly in Ghana, Nicaragua, Kenya, things like bananas or yams, and then certainly far less nutrient dense or calorically dense than things like flour. So to me, this, at least often there's like talk of what folks might call like a Western or like US centric diet, where people would say that the first thing that comes to mind is say like McDonald's or like wheat intake or like bread or soybeans. But actually, to me, what now I think of as distinguishing sort of like a Western diet is intake of basically raw vegetables. Obviously, not everyone is eating that in the US, but that the folks who are eating it, I think, kind of stand out, at least when we compare them to other folks around the world. And I think something else that's also interesting is that Americans who are eating these foods are actually not eating, or I think sometimes I noticed someone in the chat referred to like kind of this Netflix documentary about like eating more fiber. I often see marketing that kind of positions things like salad intake as say like healthier and perhaps reflecting like a less processed form of like plant intake. But actually, if you look globally at it seems people who are eating less processed plants or fruits and vegetables, they're actually eating different ones. They're eating starchy things like banana or the Araceae or yams and sweet potatoes. And it also then suggests that, also going back to Greg's talk, that what might be shaping global dietary patterns isn't necessarily like cultural taste, although I'm sure that's a component too, but that if things like incidence of enteric illness or higher risk of enteric infection associated with these kinds of like plants that are often eaten raw or unprocessed, that would require, in order to make that more common, say like greater investments in things like wastewater and sanitation. So in other words, things like wastewater treatment plants or their abundance and like cold chains, like that possibly shapes dietary preferences, perhaps as much as culture does. Or maybe that's overly provocative, but that's kind of what at least makes me think about now. I'll just mention in passing that this is still also kind of like fresh off the press. We haven't really gotten a chance to dig into this yet, but as you might imagine, I also have a kind of deep interest in extending this to foods and dietary patterns in the Philippines. So I've been super grateful to work with Noel Santos and Julia Gubat at the FNRI at DOST. And we've also, it's been a lot of fun to collaborate with Angie Lau and Paul Yu at Salle on analysis now of food-seek results involving samples that were collected from kids in Metro Manila. And it was so cool to me to kind of see now what are the most common dietary plant and animal species that we're starting to see in those samples. So you can kind of read them off here. What are common, because I guess makes sense, are things like chicken, pig, rice, coconut. Like these are things that we do see in many other settings around the world. But then too, we're starting to see plant species that I hadn't actually really seen before in other settings. things like the Singkamas or the Ampalaya is like not very common in the States. As well as what I think, I'm not sure which one is the sitaw, but again, we don't really often, I don't see a ton of that here, at least in North Carolina, when we sequence local populations here. So this is something that I'm really excited about continuing, and I'll just mention because I know people are asking about it before. I'll be on sabbatical this coming year, working with Salle and DOST, and I'll be based out of Manila. So I hope to continue this work and dive into it much more. So other things that I'll continue that we're working on, just that the lab here at Duke will keep doing, are we have approaches for working with animals as well as dietary fungi and invertebrates. We're really working on automation and trying to just make this much more high throughput. We also are developing forms of data return for study participants because we don't just want to collect data and then write papers, but we have projects where we return the data in kind of web-based forms that are, you can look at it on your phone, and so that participants can kind of see. It's almost like other sorts of genetic tests, except for food. They can see the different kinds of plants and animals that they've been eating. And we've also now been, we have many other projects going in hospital patients, in infants, and we're kind of looking at links between diet and the microbiome there. Oops. And I'll say too that we are trying to share and teach as much as possible. So in case other people want to try and replicate this, all of our protocols are on GitHub and they're publicly available, as well as our reference databases. And if anyone wants to try and replicate this, please contact me. I'm happy to kind of share what I know. And also, though, if people want to collaborate but don't have a wet lab, we also love to collaborate with others, and we've analyzed, as I wrote here, thousands of samples for external groups. So that I'll conclude by acknowledging our wonderful collaborators, both in the US as well as abroad, our sources of funding that I listed below, and importantly, our lab group here at Duke, who have carried out all of the work that I've described to you. So thanks for listening, and I'm happy to take questions if people still have time.
Okay, thank you, Lawrence. We already have one question in the chat box. So is
Yeah, so yeah.
from Dr. Asuncion. Is there a diet prebiotic that can be eaten to allow prebiotics to be taken without the side effects of soft and frequent defecations and have the microbes survive better in the gut?
Oh, that's a really interesting idea. And Dr. Asuncion might be thinking of, there are these things now called synbiotics, where it's not just a probiotic, which is a bacteria, but you combine it with a food, like a prebiotic, and that's why they synergize, and they're called a synbiotic. I don't know if there are any. I'm not aware of a commercially available synbiotic like this right now. I know people are working on it. And the best I could think about, but I don't know if I encourage self-experimentation, but if I was to hypothesize on how you would do it, there are milk-based oligosaccharides. So most of the probiotics are dairy-based, like they ferment dairy. And so if you really wanted to try, like you could probably mix in different kinds of dairy, but that's often how they come already, right? Like in yogurt. So I'm not aware of any particular off-the-shelf like fiber supplements that you could mix with a probiotic, for example. Sorry.
Okay. I think Doc Al.
Yeah, thank you, Lawrence. Definitely a very nice presentation. Just want to enlighten you a little bit on what's happening in the Philippines. We're definitely looking at, on both sides, metabolomics, looking at metabolic profile, they're trying to detect biomarkers and sugar molecules that are glycosylating proteins produced by cancer cells. We started with that with Gladys, actually is part of that work, with Carlito Librilla out of UC Davis. So there's some metabolic work that are very equivalent in terms of complexity. But I like that you're tying it in with the microbiome activity, which is also one of UC Davis, Carlito Librilla's earlier discoveries on milk, mother's milk digestion with Bifida, which is a startup company that they actually has since deployed and has probably close to $1 billion in sales now. It's a 7-year-old company already, I think. But he's also definitely a part of the collaboration. So very active past president of PAASE. So we should have at least maybe huddle to look at what we can. But the other one that just happened a month ago is a omics, proteomics, transcriptomics, and genomics detection assays for surveillance, especially for the disease killers in the Philippines, that being focused on cardiovascular disease, diabetes, and of course cancers. But one of the earlier deployment on omics is to look at the cardiovascular genomic profile that has resistance towards some of the hypertensive drugs that are out there. And of course, find a way to kind of tie it in. I just came back from Bangkok and I met a professor from NUS saying that your life expectancy is a 4321 number. 40% is due to your nutrition and lifestyle. 30% is your omics, genomics. 20% is your environment and stress and pollution. And only 10% is healthcare. So clearly what you're doing is in the first 70% of life expectancy capability. So you're in the right spot. I would love to collaborate with your capability applied in the Philippines, where we're making this effort at the National Academy level from a biosurveillance capability. So it's not really a question, but it's really more of to give you a flavor on what's happening in the Philippines. And if ever you do make it here in the Philippines, do contact us in PAASE. I'm currently chair for the board of directors, and Gladys is the president, and they both are very excited about what you just presented today. Thank you.
Oh, thank you. Yeah, I will hopefully be there sooner rather than later, and especially with Angie's help. As you mentioned before about the Balik Scientist Program, I have an application pending, and so hopefully that'll be part of it. And I'm very excited about the potential to plug into metabolomics because we can only see so much. Every assessment technique has limitations, and so we can't see the nutrients that are part of food. And so I think they're very complementary, and that's something that we would love to do in more depth, is to start linking those things. And then about cardiovascular disease, the other thing that I didn't show here, but that is also we can link to what we think is intake of processed foods, is just blood pressure. And so I think particularly when people think about stratifying cohorts in terms of, say, the responsiveness to a drug, diet, as you said, won't be everything, but at least perhaps that's a way of segmenting populations. And so when we start to see different kinds of responses, maybe we can have a more nuanced view and have a little bit more knowledge as to if people had different genomic or genetic backgrounds, maybe this explains some of the other variation that for whatever reason didn't show up in a trial.
Thank you.
Thank you.
Doc Gladys.
Hi, good morning. I'm Gladys Completo. Congratulations, that was really wonderful talk. So you mentioned about your genomic approach, the food sec, and then how it is more accurate and more reliable for the dietary assessments compared to our traditional methods right now. But how about what are the implications for your food sec approach for large-scale dietary and health issues? Because I noticed that you usually just have data where you compare a diet of one person or two. Do you have a large cohort data now, and can you use food sec for that? Or are you?
Sorry for not being clearer. So for say these kinds of plots here, each of these dots here is a different person. So these are aggregate thousands of individuals. And so, and then I think I believe it's actually possible to even do larger cohorts as well. So we are preparing to scale up where we could go to tens of thousands of people, if not more. So yeah, I would love to I think this is amenable to scaling and kind of the way that, unfortunately, COVID surveillance showed that it's possible to do a lot of genetic tests, right? And so I think that's the kind of thing that we can kind of learn from. And also just to say it, I wouldn't necessarily say that this, at least right now, is going to be more accurate than a traditional food diary. I don't want to say that even though I was mentioning that they have limitations, I think in many ways they are still the gold standard, and we're just still trying to figure out how do we compare to that. But at least in settings where people cannot collect a dietary record using like a survey, I do think that this is most certainly a helpful alternative.
Yeah. One more question. It was very interesting actually when you presented that, diversity really is not a measure, right, of a good diet, because you show that results from just eating from McDonald's. Because I'm actually doing a work on stunted children. We want to, because there's this study, right, that the missing link why interventions being given to stunted children is not that effective, even if you do high protein diet or other possible interventions, is that the missing link is in terms of the maturity of the gut microbiome. So and you measure the maturity of gut microbiome in terms of diversity, right? And then you showed in your data that the most diverse microbiome that you saw from your data is from not healthy food intake. So I think that's very interesting.
Oh yeah, and just to clear up that those were that diversity you're referring to was actually the diversity of diet.
Oh, the plants.
So
sorry, yeah, not the microbiome.
Yeah. But I know what you're talking about the link, like to sometimes it's called like enteric enteropathy disease, right? And so I'll say that the association that I'm talking about with between higher diversity not necessarily being of food, not necessarily being healthful, I would say I probably was being too general. I'm thinking of that mainly in a setting like the US, where there are far fewer stunted children. And so, in the Philippines, where, as you know much better than me, that you have the double burden, there kids with stunting, I do think that there's probably strong evidence that a more diverse diet is probably helpful or protective against stunting.
Looking forward to when you come here, and then I also have studies on metabolomics, so maybe we can discuss later once you're.
Oh, I would love to.
When are you coming? When will you be here in the Philippines?
I'm trying to figure that out right now, but I'm hoping maybe by August is the hope, but we still have some applications pending. So.
Okay, there's one question in the chat box by Ralph Turingan. Is there a way to determine the relative contribution or abundance of each species to the diet of the subject or stool sample?
That's a great question. And it's the short answer is yes. The long answer is it's complicated. So the short answer is that we do think that if you eat more of a certain food, you will have more DNA in it of your stool. The reason it's a little complicated is because the amount of DNA that is in different kinds of foods is different. So like lettuce, for example, has a lot of DNA because it has a lot of chloroplasts because they're being used for photosynthesis. Whereas other parts of the plant, like I think, for example, like inside of an orange, the fleshy part actually does not have a lot of DNA. So different plants and animals have different amounts of DNA in them, but for a given plant or animal, if you eat more of it, I think there will be more DNA in there. And so we're working on now trying to be more quantitative about those things. So we don't yet, I do think we can say that if certain people are eating more, say, beans than someone else, but converting that concentration of DNA into grams of food, that we are not yet there at. That's harder.
Okay. Any other questions? Any more questions from the audience?
Hi, Angie.
March, kayo ba yan?
Yeah, it's me. Yeah.
Okay.
Hi, Lawrence. I got a question. One of the studies that we're doing right now is about early onset colorectal cancer. So I'm kind of
Oh, wow.
wondering, because there seems to be a lot of connection with the microbiome. Have you correlated the diversity of the plant species versus the diversity of the microbiome that's present in your stool samples? Because obviously you have a lot of stool samples that, have you looked at those?
We have, and it's actually the exception when there's an association. So we see an association sometimes in very young children or people who are taking very heavy courses of antibiotics. But otherwise, people who are just sort of normally healthy, we actually don't see strong associations, which surprised and honestly initially disappointed me, because that's exactly why we started those studies, is we thought there would be more tighter links to the microbiome. I'm really excited to hear about your project. Do you happen to collect stool samples?
We have not really. That's one of the things that I was interested about, because particularly since you mentioned about antibiotics, we're looking at the correlation between antibiotic use, diversity of microbiome, and how that affects particularly diversity at the early stage of life when you're taking antibiotics, and how that correlates with risk for early onset colorectal cancer. And so we've been using a lot of mouse models to look at that, and we see that repeated use of antibiotics actually sometimes increases the risk of early onset colorectal cancer in our mouse models. But it's harder to track in humans because you have to follow them throughout their lifetime, which is why we have to model them in mice. Yeah.
Oh,
so I'll be
yeah.
interested to see your data on those kinds, on the antibiotic diversity, the food, and also the correlation with the microbiome.
Yeah, and I look forward to connecting. There's another PhilAm researcher here, Andrew Chan or Andy Chan, who does wonderful work around nutrition, the microbiome, and colorectal cancer. And I think he's also had an interest in potentially connecting. So I can help triangulate too.
Yeah, we need to get together at some point.
Yeah.
I
thought I saw did Dr. Asuncion have another question?
But I think Doc Asuncion. Do you still want to ask the question? Do not use AM. So, okay. I may naka-raise ng hand. Dali,
Al.
Al.
Yeah, well, I'll have you here, Lawrence. What do you think of fecal therapy, that they take the fecal and then they ingest it for inoculating somebody else's, not only a relative, but to do seeding for their microbiome in their own, to address particular digestive problems? Since I have you here, might as well. I saw it on Netflix, by the way, so thank you.
Yeah, so it has, then you're probably aware, it started because, it got a lot of attention because it seems to be highly effective for treating recurrent C. difficile infections. So I think it seems pretty established at that point that it's going to be a viable therapy. I don't know if I've seen conclusive evidence outside of recurrent C. diff, whether or not there's fecal transplants are going to be considered a mainstream therapy, because it turns out that they carry also other kinds of risks. So there's been some
Yes.
evidence that like obesity, for example, might be transmitted
Depression
via FMT.
and also even pimples. I think.
Yeah,
So-
so I would be cautious. And I don't I think more definitely it's still at the experimental stage. I don't yeah.
you won't recommend it.
I think
unless you have C. diff.
Okay. Okay. Thank you.
There's a lot of correlation between the role of fecal microbiota transplant and, in fact, even immunotherapies for cancer. But unfortunately, the problem with it is that it's very undefined. You don't know what you're putting in. And so the goal is actually to dissect what are those species that are in there that are beneficial and what kind of metabolites they have that can actually then be defined and used with whatever disease you have. Because right now, fecal microbiota, you have no idea what you're putting in. And it can be beneficial,
and especially
it's not.
in like a cancer therapy, right? Like the patients often are heavily immunocompromised. And so I think you want to be very careful about exposing them to bacteria.
You're right,
So,
yes.
Okay, any yes?
So maybe we can anesthetize or pre-select, I guess, the therapy first. Disinfect, for lack of a better word. At least for particular harmful bacteria contamination in the fecal matter before you actually take it on. So just a thought.
It's
but
hard.
thank you, Lawrence. Very, very informative. Looking forward to you in August. I hope we meet in person.
Yeah. I hope to make it over by August. And so yeah.
Fingers crossed.
Yeah.
Hey, again, thank you, Lawrence. I think there's no more question from the audience. Wala lang question from the chat box. Okay. Yeah, and then I think that ends our webinar for today. And we thank all who attended today. We actually reaching 100 participants, so it's a good number for the webinar.
Very good.
Yeah. So thank you.
Can we announce for the upcoming APAMS, if you don't mind? Oh, too bad, Lawrence, you will miss it, but we'll definitely invite you to go to UP Los Baños to give a talk. There's a lot of faculty members that would be interested to be your collaborators. So for everyone, I would like just to invite our audience to come and join us this coming July 13 to 22. It's a 10-day caravan celebration of the 44th year of PAASE, with our theme, Filipino scientists across borders towards developing regional science and technology innovation ecosystems. So we'll be starting at University of Rizal System on July 13 to 14, 2024, with the theme, Technological Innovations Towards Sustainable Education, Agriculture, and Ecotourism. And it is followed by going to University of the Philippines, Los Baños on July 15 to the 17th, 2024. And just letting you know that we already reached the maximum number of registered participants. So we really got a lot of response in this site. So our theme is technological innovations towards health, food, and nutrition security. And then next is in Batangas State University on July 18 to 19. And the theme is towards smart cities, communities, and responsible use of AI. And then it will culminate at Eastern Visayas State University on July 20 to 22 naman po, where the theme is technological innovations in disaster risk and reduction management towards resiliency. Okay, so please do go to, and who are our target audience? STEM professionals, educators, school administrators and students, researchers, academics, advocacy groups, elected officials, our policymakers, and government representatives. So please go to apams.paase.org so that you'll find all the details and all our speakers. Please join us. Thank you very much.
Okay, thank you once again. Don't forget to fill up our evaluation link for those who are here. And I think
We have a picture now with Lawrence.
we already did the picture taking a
Ah,
while ago. So I think
okay.
pwede na yun. We already have a group picture.
Okay.
Yeah, okay. So may question. Okay. Yeah, so don't forget to fill up our evaluation link, and I think you will only get your certificate after filling up the evaluation link. So for those who are interested now to get a certificate of participation. Okay, may mga pumapasok pa na participants. We are already
Yeah.
closing the session. Thank you again. Have a nice day, everybody.
Thank you.
Thank you again. Bye.
Bye.